Have you ever pondered the mystery of how atoms bond to form compounds? Today, we will dive into the world of atomic bonding, exploring the two primary types, ionic and covalent bonding. Picture this: a metal and a non-metal react. Electrons are transferred from the metal atoms to the non-metal atoms, forming ions. This results in what is known as an ionic compound. For example, when sodium reacts with chlorine, it forms sodium chloride. Similarly, magnesium and oxygen react to produce magnesium oxide. In these reactions, the metal atoms donate electrons to the non-metal atoms, creating positive and negative ions respectively. But what binds these ions together? It's a strong electrostatic force of attraction between the oppositely charged ions, known as an ionic bond. This powerful bond is the glue that holds ionic compounds together, from your table salt to the magnesium in your multivitamins. Now imagine a different scenario where two non-metal atoms share a pair of electrons. This sharing results in what we call a covalent bond. The electrons involved are in the outer shells of the atoms. An atom that shares one or more of its electrons will complete its outer shell. Covalent bonds are strong and require a lot of energy to break. Substances with covalent bonds often form molecules with low melting and boiling points, such as hydrogen and water. These substances have strong covalent bonds within the molecules, but weak intermolecular forces between the molecules. This means that only a small amount of heat energy is required to separate the molecules from each other. After bonding, the atoms are stable as they have a full outer shell of electrons. Both nuclei are strongly attracted to the shared pair of electrons in the covalent bond, reinforcing the strength of covalent bonds. Interestingly, atoms may form multiple covalent bonds, sharing not just one pair of electrons but two or more pairs. Atoms of different elements will form either 1, 2, 3, or 4 covalent bonds with other atoms. The number of covalent bonds an element will form is 8 minus its group number. For instance, carbon in group 4 forms 4 covalent bonds, while oxygen in group 6 forms 2. To sum it up, ionic bonding involves the transfer of electrons from a metal atom to a non-metal atom, creating positive and negative ions that are held together by a strong electrostatic force. On the other hand, covalent bonding occurs when two non-metal atoms share electrons, resulting in a strong bond that requires significant energy to break. Understanding these fundamental concepts of atomic bonding helps us better comprehend the world at a microscopic level, from the formation of compounds to the properties of everyday substances. So the next time you sprinkle salt on your fries or sip a glass of water, remember the intricate dance of atoms and bonds that make it all possible. And remember to like and subscribe and stay curious.